Hi guys, I'm going to go over how to complete assignment 2 for week 2. So our learning target is I can explain how an electrochemical cell works. So our lesson was about how these electrochemical cells function and what are the different parts. So you have 2 Regents open response questions for your homework. Here's one, and the second one is down here. So this is going to be a read through of the questions and me sort of explaining how to answer the questions as if we were in class together. So question 1. The diagram and balanced ionic equation below represent 2 half cells connected to produce an operating voltaic cell in a laboratory investigation. The half cells are connected by a salt bridge. These terms should sound familiar to you because you already watched lesson 2 for this week. 1. Determine the oxidation number of nitrogen in the negative ion in the aqueous solutions. 2. State the purpose of the salt bridge in this voltaic cell. And 3. Explain in terms of atoms and ions why the mass of Mg solid electrode decreases as the cell operates. So question 1, determine the oxidation number of nitrogen in the negative ion in the aqueous solutions. So you have to go and look at your aqueous solutions here. You have 2 of them, and they both have this nitrogen compound in it. Now, something to note, when you see these parentheses, that's referring to a polyatomic ion. So we have to look at table E for our polyatomic ion. I have it on this tab over here. And we see, if we look, NO3 is right here. It's a nitrate polyatomic ion. It's NO3 minus 1. So what you're actually solving for here is your oxidation state on NO3 minus 1. You could ignore the fact that there's 2 of them because you're just focusing on what is the oxidation state of this nitrogen. You should be able to figure it out based off of what we learned in lesson 1. Okay, number 2 is pretty straightforward. Number 3, explain in terms of atoms and ions why the mass of the Mg solid electrode decreases as the cell operates. So you have to look at your diagram. Our Mg solid electrode is here. Think back to the video that we watched. Why would this Mg electrode, why would the mass decrease as the cell works or operates? Okay, you're filling your answers in these blue boxes. Second question. A student constructs an electrochemical cell during a laboratory investigation. When the switch is closed, electrons flow through the external circuit. The diagram and ionic equation below represent this cell and the reaction that occurs. So when this switch is closed, electrons will flow through the circuit. Question 1. State the form of energy that is converted to electrical energy in the operating cell. You might need to look at your definition for what a voltaic cell does to get this answer. 2. State in terms of the copper solid electrode and the zinc solid electrode the direction of electron flow in the external circuit when the cell operates. So basically it's asking you, are electrons going to flow from copper to zinc or from zinc to copper? I encourage you guys to look at this equation here, and you want to pick out what's being oxidized, what's losing electrons, what's being reduced, what is gaining electrons. Once you can identify what's being oxidized or losing electrons, you should know which one of these will be giving the electrons to the other and which direction the electrons will be flowing. So you have to dissect this equation down here. 3. Write a balanced equation for the half reaction that occurs in the copper half cell when the cell operates. So basically, what is the half reaction happening on this side of the cell? Again, we need to look back at our equation here and we need to isolate. What is copper doing? So let's look. Copper is here. Now analyze it. Is it losing electrons? Is it gaining electrons? What would your half reaction look like? Remember, in your half reaction, you should have you should have a reactant side, a product side, and then you need to figure out, where do I write my electrons? On the left or on the right side? Okay, and last one. State what happens to the mass of the Cu electrode and the mass of the Zn electrode in the operating cell. So as the cell operates, what happens to the mass of the copper solid part and what happens to the mass of the zinc solid part? Again, if you have any questions, always feel free to email me, and good luck.